Hi, Professor Dave here, doing another example for a hypothesis test for a mean. In this example, suppose that you thought that the average amount that people slept was 7 hours. You sampled 40 students or people and found that their average sleep time was 6.8 hours with a standard deviation of 1.2 hours. Use alpha 0.05 or confidence level of 95%. Can we infer that the average sleep time is less than 7 hours? Okay, so let's set up our hypotheses. We usually set up the alternative first. So that would be, we're trying to infer whether it's less than 7. So let's say less than 7. And the null hypothesis always keeps the equal sign because we have to anchor our assumption so that we can calculate a p-value. And that can either be greater than or equal to 7 or equal to 7. I put equals to emphasize that the equal sign must go there. Okay, so alpha is 0.05. And the first thing we have to check is, does the sample result possibly allow us to infer the alternative? Because if our sample mean was, say, 9.3 hours, then there's no way that we could possibly infer that it was less than 7 hours. So we have to check that. And our sample mean is 6.8 hours. Okay. And so we could possibly infer the alternative because 6.8 is less than 7. So key point, since 6.8 is less than 7, how come we don't just automatically infer that it's less than 7? And the answer there is that, well, we took a sample of 40 students, okay, 40 students or 40 people. And it's quite conceivable that the true population mean is equal to 7 or greater than 7, and yet we get that sample result. It could be within sampling chance because sample results vary. Right? Since sample results vary, we have to see if it's significantly less than 7, if it's not within sampling chance of 7. So we have to calculate a p-value. All right. So so it does. So then we can calculate a p-value. So what's our p-value? Okay. So for this class, I'm using a TI-83 calculator to calculate p-values. There's many ways to do it. You can do it manually, but this is the way we're doing it here. So let's turn it on, clear. We go into stats and tests, so I'll shoot over to tests. And it's a t-test for a mean because the realistic picture is we do not know what alpha is, the standard deviation of the population, since we don't even know what the mean is. Okay. So we have the summary statistics. If we had data, we would go here, but we have summary statistics. The hypothesized mean is 7. Okay. And then the hypothesis mean is 7. Our sample mean is 6.8, and our sample standard deviation is 1.2, and our sample size was 40. Okay, and we have a less than, so we'll take a less than and enter, and then we calculate. And we see a t-stat of basically -1, all right? And that's basically a z-score, which is not too far. About 68% of the data lies within one standard deviation, so it's not too unlikely. On the one side, that's about 15%. So I'm going to write a p-value of 0.15, okay? Now that is not less than alpha, okay? That is not less than alpha. So, so that's not unlikely enough. You know, we're looking to see if we're going to assume HO, that the mean is 7, and if we get some sample results are really unlikely under that assumption, then we'll reject HO. Well, 6.8 turns out that it's not very unlikely. You know, 6.8 is relatively close to 7, but the probability of obtaining that sample result or more extreme, which is what a p-value is about 15%. Not that unlikely. Not less likely than I am to make a type 1 error, which is wrongly rejecting a true null hypothesis. So, since the p-value is greater than alpha, do not reject HO and conclude there is not sufficient statistical evidence to infer that the average sleep time is less than 7 hours. So there we go. Hope that is helpful.